All right. So for those of you who weren't here 5 minutes ago, I basically decided I want to play some Shenzhen IO. I'm feeling a bit tired today. Don't really want to code anything right now. It's Saturday. Just gonna have a good time. So yeah, that's all the intro I think this needs. It looks like my dashboard's lagging behind a bit, by the way, so I'll probably miss some chats or whatever. So sorry about that. Also, check this out, guys. I got follow alerts now. Fancy, right? Okay. I actually haven't opened this game in a couple weeks, so I probably will take a minute to get reacquainted with what I've done here. First of all, this is the very first puzzle, and what I hate about this is apparently this can be done in 57 cycles. That just infuriates me. Or sorry, 57 power units, I guess. TJ, long time no see, bro. Yeah, man, it's been forever. I'm also getting over a cold, so if I sound a little sick, that's why. Yeah, usually what I do when I open this thing is I just go through all the puzzles and see if I've beaten any of my friends. There's a couple of these, like here, he's got one less power unit than me. So I might want to fix that. Or I might want to solve some newer problems, but I remember some of these started to get pretty annoying. I think some of these later ones where I'm really not doing well in terms of the bill curve, that's usually because I only solved it once and didn't bother optimizing some of this stuff. I think I'll actually even just look at this first one again, see if I can if I can do the reduce power. As you can see, I did a couple attempts at this. By the way, if you guys have not played this before, there's going to be spoilers. Also, I might actually have to enable screen sharing on this because of I probably need to like look at the documentation. But we'll see. I'm gonna eat some cheese. So let me go over this original solution. Yeah, original low lines of code. This is 3 lines of code for the first one. Now again, if you guys are unfamiliar with this, the basic idea is you have this like a bunch of these different puzzles to solve, and they generally take the form like you have an input here, or you have some inputs, and then these are the outputs you need to actually produce, right? So in this case, you're doing this like thematically, it's like a fake security camera. So you have one light that turns on and off that's supposed to be like your power light, another one that turns on and off is supposed to like fake a network light. And what you do is you wire up a bunch of these little microcontrollers and some extra other bits, and then you run the simulation, and it will either produce the correct or the incorrect output. In this case, of course, it's correct. This is the very first puzzle, but I was able to do it in, as far as I know, the lowest possible lines of code possible. And I'm able to do that, of course, with an undocumented opcode that basically generates a square wave on a target pin with the amount of cycles it's supposed to be high and the amount of cycles it's supposed to be low. So like in this top one, it's just supposed to be this basic square wave here. Now, if I normally just did this without this little bit here, we're going to get basically the right pattern, but it's flipped. So that little component I had in there was a NOT gate, which effectively flips the Boolean value here. pretty simple. The second one's basically doing the same thing, but it has to generate a couple different waves. So for example, it generates one where it's high for 4 cycles and then low for 2, and then another one where it's high for 1 cycle and then low for 1, and then the whole cycle repeats. And then again, we put that through one of these inverters here, one of these NOT gates, and we're able to get this actual pattern. The crap thing, though, is I know that people are doing this in 57 power units. And I call them power units because I don't think the documentation ever explains what that's supposed to be called. And I did a couple attempts at trying to fix this, but I don't think they ever got much lower. Like I tried basically removing components, removing those NOT gates. Of course, that didn't seem to affect power at all, if I remember correctly. But basically here, like if you want to generate that same pattern, you can still have this like same square wave. And if you delay it by 6 cycles, which is what this will do, this sleep will do, and then this at will only make sure that that's executed the first time it's ran, because it'll loop the code around, but then it won't execute that after that. You'll get basically the same pattern as you would with just doing this and then the inverter. I keep calling it inverter, but it's really a NOT gate. Which I shouldn't do, because when you're talking about embedded circuits, those are that actually means something in that space. Yeah, I did the same thing here, but again, I wasn't able to get the power usage down. And the reason why I was trying to do that, though, is because, like in this case, with just the low line of code one, this ends up being, I think, 60 power units. I think both of my attempts were basically this, and I didn't get any farther. Because I'm not really sure how you would spend less power. Basically, the way that the power works, this instruction is kind of like a macro instruction, so it doesn't really follow the same rules as the other ones unless you can break it down into equivalent instruction, which really is move P0 100 sleep 6 move. 100 P0 sleep 6 move 0 P0 sleep 6 again. I believe this has exactly the same power. Was it now 58? If we do this, we'll get one less line of code. But we're at the same power usage. Basically, the rule appears to be every time an instruction is executed, it will use, we'll use 1 power unit. Except, so for example, every sleep that executes is 1 power unit. So even though this is sleeps for 6, then that's another 6 cycles that won't, or another, it seems to use 1 power unit for the first cycle, and then the other 5 cycles, it won't use any power as far as I can tell. But then this one will use 1 power, this one will use 1 power, this one will use 1 power. So we want to just reduce iterations here. And it might actually be possible to reduce this in the same way, but I honestly don't think so. If we break this down again, we have move 100 P0 sleep 1, move 0 P0 sleep 4. Should be the same there. And then we can, of course, do this. And this is basically the other than the other gen here, it's basically the solution you come up with initially. I still don't know where you could actually shave that extra bit of power, though. Because usually the way you'll do it is you'll make it sleep for longer or something, or just run less instructions generally. I'm not entirely sure how we can do that in this case. Because just running less instructions here doesn't necessarily help, like we saw from the low line of code solution. Not really sure there. When it loops around, that doesn't seem to affect power usage at all. It seems to just be whether or not you're executing instructions. And this Gen 1 ends up taking the same amount of power as the individual instructions that would have made it up. It's more of a shorthand, which is really nice for lines of code, but doesn't really help us otherwise, as far as I know. So again, we can expand that. Move 100 P0 sleep 2, move 0 P0 sleep 1. Should be the same 58 power. The fact that we're already starting with sleeps here is generally a good thing. I wonder if it's honestly possible to just like reduce a cycle if we just like flip one of these. Because sometimes these kind of like moving code around like this really helps in this game, in a way that's a little bit counterintuitive. Because I think you generally end up with like, if this happens, then in the last cycle we might not actually execute an instruction. There's usually those kind of situations, which is so annoying. It's so annoying. See, like even just moving that around, we now are using 59 power units, right? See what I mean? So like that stuff totally actually has a bearing on the solutions in this game, which is something I both love and hate about it. And I think that's why the low line of code solution I have is 60 power units instead of this one's 58, because we're able to sleep in the beginning here, whereas the other one didn't do that to try and save lines of code. So that's fun. Just changing my music really quick. I'll post what I'm listening to when I get there. There's this album called Let It Roll, which I think is a drum and bass festival. Happens every year. And they had a really good compilation album out last year. Let It Roll Volume 1, it's called. Let's go ahead and paste that in the chat there. In particular, I'm listening to the song Metamorphosis, which is 16th on that list, if you guys have Spotify. That's pretty cool. Anyway, the only way that I can think that we might be able to use less cycles here is, again, that kind of alignment. So, like, the fact that we're sleeping in the beginning here is basically the best we can do. I'm wondering The problem is I can't really put any larger microcontrollers here because they'll fall off the board. But I'm just kind of thinking, like, I wonder if there's a way, like, if there's another move over here to get rid of that or something. You can't, like, put bridges between the boards either, which is a shame. I mean, I guess it makes sense, but in the rules of this little universe. So how can we shave that last bit of power? Could, for example, like, step through this and see how it goes. See, as I'm just stepping through here, you can see it basically runs very few instructions. See, the power goes up. I'm just looking at this initially. So, like, initially there's no power. I think it does like one power for like instruction fetch, I think they call that. Or maybe that's just the sleep that I'm seeing there. I'm looking at this top one. Okay, no, so it is basically just every instruction that's executed uses one power unit, except that gen one, which can use multiple because it's basically shorthand for the actual instructions that are equivalent. That seems to be consistent here with the rules. And what sucks about that is we end up like this situation here where it's just like sleeping for one. I don't like that. I wish I could get rid of that. If there's a way to change that, that'd be nice. Again, with like that alignment, it may actually be that we can like do the move here. But I'm pretty sure that will increase the power usage. Probably by 1. Yeah, because now we're executing that extra instruction there in the beginning. And I'm guessing this one will have the same issue. But it might not, just the way that things are aligned. But it probably will do the same thing. Yeah, up at 59 again. That's just generally how this seems to go. And I'm wondering if that last one comes from this. Or no, because this would be sleep 1, 4, and then we move 2. Or yeah, move this, and then sleep 2. So I wonder if we go way out there to the end, what's actually happening here. Just want to see what instructions we're on, which ones actually end up executing here. Right, and it's going to sleep 2. Okay, so in that case, it actually didn't execute that last one. And I don't think it would help to do something like, just to be cheeky and just see. I think we'll end up with the same amount of cycles here. The same amount of power units. Yeah, still 58. So I'm really not sure how to get this one to use any less power. Yeah, I might shelve this one again for now. Get rid of this one. Might be onto something there, but I'm not really sure. Because at least we can like make it cost one more power unit, but not use one less. I'm really not sure how to do that. This guy did 4 less power units than me, so I might want to fix that one up. I can show you my low lines of code solution, which again, also if you look at the bell curve here, this can actually be done in 3. So I wonder what that is as well. There's a problem with this game. I spent so much time with this like optimizing that I'm not solving any of the harder problems. So this is, I believe this is the control signal amplifier. So we take an input on P0 and we basically want to double it and put its output on P1. So my solution is to move P0 into the accumulator and then add the accumulator to the implicit argument of itself, which is going to, add a number to itself. It's the same thing as multiplying it by 2. If I do like a mol 2 there, it ends up being the same amount of power in this case and the same amount of instructions. And then I'm going to move that accumulator to P1 and then sleep 1. Thordman says, eat a step D to advance space to simulate. Nice. I guess that's when I'm not selecting that. Yeah, that's pretty cool. That's helpful. Nice. So if I'm going to reduce this one, like one of the things that I really like about some of these tricks is you can do like, with this gen opcode, you can generally like say, oh, it's going to go to P1 and it's going to be up for, 1 or whatever. You can actually have it be like 0, or you can even have like a accumulator here in some of these arguments. So I thought that I could maybe smash these two together and do like P1 AC 0. But you don't end up getting the same thing because this is a specific level. So that ends up not working, even though that's the kind of trick that ends up being really helpful in other places. But that's usually when you're dealing with like the stuff in your accumulator has like time values. Not so useful when it's like levels like this. The simple values, I think they're called in the Shenzhen lingo. So aka Citra says you can reduce it by using logic gates. Very interesting. So one of the things I thought of in this is because what are 3 values are 0, 50, and 100. aka Cetris just gave me the answer. or did he? He's saying you can reduce it by using logic gates, because the not gate in particular will automatically give 100, or not will give 100 once it receives 50. So let me just hook that up really quick. If you do like not and then feed that into another not, I'm assuming is what he means there. Which is fun routing here. You can do that. There's not. Okay, so interestingly enough, if I remove the add, for example, then we get the correct value when it's 50. But then we have to handle the 25 case. By the way, I hope this was... Is this the same one? Just to make sure I'm not losing any work, just in case. Yeah, okay, we're fine. Okay, so it just says simple output pins work, so if you connect several outputs together, then the wire has the value of the maximal output provided. Man, I did not know that. I guess you would have had to find that out by experimenting. I don't remember seeing that on the docs, at least. But I guess... So here's the issue with that. I only have... Let me try to figure out how to wire this. I think what he's basically saying that you could, if you basically take the control input here, and then also connect it to the output here, so we have the same input like this. How am I gonna route this? Let's just try. This is one of the things I don't like about this game, is that routing tends to be really annoying. Yeah. Bet we can actually just do this here. That ends up being... I think I see what you're saying, AK Citrus. I just got to figure out how to route this. Because basically he's saying that, like, if you just wire this up like this and don't use any of this stuff, which I'll just do that, for example, it actually gives you the right solution in the case that it's 0. Routing. Yeah, saying control in just to control out gives you a third of the solution. So AKA Citrus is basically giving me the answer. And I'm going to take it this time. But after this, I actually don't want any more solutions. Hints are okay, but this is a bit too straightforward. But it's nice that I didn't know this trick, because you could basically, if you do this, then you get not the right thing. What if that's because this went high again here? So if I just do this, then we get the correct solution when it's going to be 50 here, because this boosts it to 100. Right, now if we just do this, we'll get the correct solution when it's 0. If we hook them both up, it seems to latch this value, and I'm wondering if it's because it's... Okay, so just no worries. I didn't set the right expectation, so I appreciate the help. No worries. So I think what you're trying to describe is something like this, where this will do the correct solution if it's 25. Yeah, he's saying the knot wire is routing to itself, which would make sense here, because it's the knot goes back here. So somehow we need... If only this thing had diodes. Yeah, wrong here. I wonder, though, if something like this still works. Because this actually this right here gives us a solution in both cases where it's 0 and 100. So if we did the other case here, could do something like move P0 ACK. We'd still need to do a sleep 1 here. Or no, because we actually don't need to do that. We just need to compare P0 25. Is it compare? No, it's TEQ, isn't it? Too many different assemblers I've been playing with recently. P0 25, and then if that is the case, we can do move P1. See you later, Alcama. I don't think this will actually work. Yeah, because we'll get 25 in this like base case here. Because we never ended up setting this to 0. We'd have to do it in this case. I wonder if that get that. So that doesn't give us the correct. Okay, yeah, of course, because this needs to be 50. So that'll give us the correct solution. But we're still at 4 lines. Power usage is way down, though. So I'm pretty happy about that. Yeah, AK is setting once you move a value to the output pin, it stays that way forever. You need to set it back to 0. You know what I can do, though? Since these only ever stay at a value for 1 cycle, and then we can basically sleep, we can bake the sleep into here. So we can do something like gen P1 0 1, or in this case, no, it doesn't work, because then we don't get the sleep in this case. We need sleep 1 here. That has to be 50. Interesting though. I'm gonna set this back really quick, just because that was my lowest power solution so far. So I'm gonna fork this as the low power solution that I have right now, and then we'll keep moving ahead with this. With this low lines of code. So I don't really care about power usage in this case. But then we're not sleeping in the other case. Excuse me, we're not sleeping in the other case. So I wonder. Because unfortunately I can't do this gen and sleep thing if the value that's writing out is not 100. Okay, so it just says he's done it in 146 power. Cool. I'm just going to verify this again to see what it was. Definitely not 146, but... At least that's the best I got for now. I'm going to keep working on this low lines of code solution. So I wonder... There's the simplest. With this other configuration handling the other ones. Okay, Citrus, if you want to say power, you need a lot of conditional stuff like running and like not running commands without needing them. Yeah, I've done that in a bunch of the other puzzles as well. Like, I don't know if you caught in earlier. I've solved a fair amount of these. It's just trying to beat my friends now. Not playing that this much. He also did it in 3 lines of code. Yeah, that's what I'm shooting for in this case. I like this though to solve it 2/3 of the way, but the problem is we need to basically compare the value and sleep for the 25 case. But I want to stick with this. I like that quite a bit. Okay, Citrus, yeah, Impetus just jumped into the stream as no one streams Shenzhen. I like this game. Yeah, it's a pretty cool game. It's something I should play more and stream more. Mostly I usually just stream programming. but felt like playing this today. Hmm. Okay, Citrus, I thought you were an experienced programmer but new to this game. That's still generally true. I haven't played that much of this. So that's not inaccurate. I did maybe not a lot of them. I got down to the Cool Dad one, Three Kingdoms. I didn't do any beyond that because then they just started to become a lot more about like routing. Whereas I really liked trying to compete with my friends' scores a little more. So I didn't enjoy the later ones as much. But this is what I really enjoy, trying to figure this stuff out. So how could we get this down? So did I complete the data routing mission? Is there one that's actually called that? Because I don't think so, if that's the case. I got to the sandwich. I did the Three Kingdoms one. That's the latest one I did. And there's a couple that I didn't do before that. Like the laser tag one, it was really annoying. And I definitely didn't get good scores on these. Because so we basically have to do this conditionally. Let's be cheeky and see what happens if we move 50 into P1. Then that should still be correct two-thirds of the cases. Data router is 7 levels after 2A27. I definitely didn't do that then. If only I could bake the sleep into this. Yeah, okay, Citrus, if you figure it out, that's cool. Quite curious. If you sleep, that's cool too. Okay, Citrus says only 5 more minutes. What I said to myself an hour ago. I had that exact experience yesterday with the other stuff I'm working on. Then I ended up waking up at like 2 in the afternoon today. I'm not good at sleeping. The problem with checking if it's 25 and then making it 50 is it's like the same thing as just multiplying it anyway. With this sleep. Interesting. Because AKS they're just saying you can use a bigger chip in a billion conditions, but I'm trying to solve it in 3 lines of code. So I don't think the bigger chip would help here. Would probably help for power, but not for low LLC. Billion in unary count system. Yeah. I want to do low power eventually, but probably not now because I'm already beating my friends on Steam. If you want to add me on Steam, by the way, feel free. If you want to share scores, I'm Ferris on there. YUPFERIS. But yeah, I really want to get this in 3 instructions. I wonder. No, because I'd have to load it into the accumulator. I was thinking about like doing a subtract and an add or something. Doesn't really help though. Thirdman says, I believe the 3-code solution uses a ROM component. So I thought about that too, actually. Here, I'll go ahead and accept that friend request, etc. When I figure. I thought about that too. But then the problem was routing was actually really tough. The other guys that I think just added me. Now I can see the scores. That's pretty fun. Oh, Cetrus, yeah, you did get really good power on here. Kind of curious at your other scores now. He beat me here too. Nice. Cool. None of us have gotten the 57 power usage on this first one either. That's funny. Amplify says, you know about routing below components, right? I thought I did. But I didn't see how I could apply it there. Wonder if I can, though. So if I'm just going to fork this again. And just try to use the ROM here, because it was those X inputs that were giving me trouble with the ROM solution. Because we have to have, like, if we do... This one's a ROM. Oh, I guess there is room here, because we can do, like... This one goes to... Is that how you do that? Does that work to route that there? Yeah, I have no idea how that first one is done in 57 power units either. apparently this works, which is cool. And then this one, I guess you can just route it through this. Can you just route it through there? No, because you connect it to itself. Because then it's like, how do you get this to the output? Because you get these connected to self things here. Because the thing is, you need to get put the address on the same side that you get the data from, as far as I know. Otherwise, this would be relatively straightforward. Then again, so that's if we did address data here. Yeah, because we'd have to get the address from here to there. Maybe that's all we need, actually. And then we can throw the data in here and do this. And that probably works, right? Maybe that's what you guys are screaming at me already. If this works, then we should have what we need. By the way, guys, if I don't see your Steam invites, feel free to poke me, because I'm just not really paying attention to that. But I'm happy to accept people, so just let me know. I don't mind spending a lot of time optimizing these earlier puzzles. I think that's more fun than doing the more complicated ones, actually. Because when it gets sufficiently complicated, I'm just like, I just want to do real code. But when it's these smaller ones, then it's pretty fun. Okay, so in this case, what we can do, then we just need to decode P0, which I believe, because that's going to be 0, 25, or 50. I need to check the datasheet for how to actually use the ROM again. Yeah, I know it's possible in 57. Ah, that bugs me. No idea how it's done yet. But I need to pull up the datasheet here to see how to do this. If you guys want me to show the datasheet on the stream, I can move around a bunch of windows and stuff. But if you don't mind, it'll just be off stream. Okay, so just he's not a druid, he's a shaman. That's black magic. No kidding. No kidding. So actually, so we know the input's either going to be 0 or 25 or 50. So like, what are those modulo 14? And that should give us the actual inputs. And then we should be able to do like move P0 X0. And then the data move X1 P1 and then sleep 1. And if the addresses wrap around, then we should just be able to put the right things in the cells. Oh yeah, Thornman says place it and see where the pointer goes. That also works. Okay, I went to this one. So that's the 0 case. No, wait, that's not, because that was the that's 25 case. So let's stick 50 in here. Oh no, sorry, 50 here, and then it incremented. Which we don't care about, because we'll just set the data pointer again after. Okay. And 0 should correspond to 0. Which should be fine. And then what does 100 correspond to? Or sorry, yeah, 0, 25, and 50. What does 50 correspond to? Was that here? Guys. Ah, thanks, Enigma Blade. That was totally it. Oh, that's funny. There it is. There's the 3-line solution. So that was actually pretty cool. So first of all, thanks AKA Citrus for that tip to do the not thing, because that was pretty cool. It didn't end up being useful in this particular solution, but that's a really good trick. Yeah, and I totally wanted to use a ROM for this before, because I was thinking sort of that same thing. Not necessarily that the addresses would wrap, because I didn't get that far, but I didn't realize you could have this funky routing. I knew you could route under chips, but I didn't know it could do, yeah, that this would actually count as a connection. So that's pretty cool. Team effort. All right, so this is now my low lines of code solution. Just get rid of the other ones. So that's the best score I'm seeing here. I should have copied out a low cost. I can just do that again. I'm just gonna do a new low cost solution just so I don't lose that. Whoops. Even though I've already solved this, I'm just gonna do this so I have them all here. And this, of course, is trivial if you actually want to do it that way, because you can, as far as I know, just do what I had basically the first time, where you take one of these and you just move P0 ACK, add ACK, move ACK P1, sleep, and I think you get the same thing. Okay, cool. I don't know if I want to dive into the low power one now, because I know you can do it with a lot of like that branching. Amplify says looking forward to the scores tomorrow. Gonna sleep. Cool. See you later, man. I don't know if I'll be playing this for much longer actually, because it's getting a bit late for myself as well. But this was fun. And I have some new friends to compare scores with, so that's pretty cool. That is totally the part I find fun about this game. And I don't know how I got this lower. 141, I'm not really sure. Okay, Citrus says, I think low power is easy. Third man gonna also add you when I get to computer. Yeah, feel free, man. And if I don't see it right away, feel free to poke me. Gonna add some more people here. I think that's cool. Yeah, why not do the low power one? So for low power, I think the Thirdman says, I tried to lure my brother and my cousin to play this, but no luck. For me, it was a pretty instant pickup. Could still do that not trick, which is pretty cool, and still covers 2/3 of the cases. And if that is what we do, then we basically just need to do the 25 case and try to make it as conditional as possible, which I don't think is the worst solution, actually. AK Citrus says, I still got 146 and can't do lower. Wonder if I just try a really naive solution here. This is 180 powers 3 commands every tick. This is definitely going to do that. 133 is only 2.21 every tick. Interesting. Thurban says something needs to be done to that move 0 since it's not needed to be called every time. Yeah, that's definitely true. If we assume that P1 is already 0 here, then being the 0 case, this covers that. And I think that happens at least enough for that to make sense here. In fact, I wonder... What if we did this? That still covered these cases. And then here we did move P1 25. We have a label here. Oops, sorry, 25 P1. I usually get that wrong because I'm used to doing right to left assembly. So if this move 25 into there, we could have some kind of, I don't know, some label. I'll figure out a name when I finish figuring out the thoughts. We really only need to check if it's 25. Or if it's 0. Yeah, this only works if we do this, actually. I want this to be able to wrap around. AK says, I don't think the first value will be 25 in every test. Yeah, that's kind of what I'm banking on here. Might not be. I want to try it. That is what that's for. You have that. You're reading that right. And that would allow us to wrap around again as well. We actually always want the sleep in that case, though. We need this then. We can do P0, 25. And if it is, move 50 P1, sleep 1, move 0 P1. Maybe that doesn't work though because of the... Yeah, that didn't work. Yeah, it's because of this extra sleep here. Not quite. Oh yeah, because we need a 50 here, first of all. I'm just trying to get rid of this base case, but maybe I'm doing that prematurely. I'm not actually sure why that didn't work, because what I was trying to do here... Oh, I guess because it ruins the logic here. Because we still end up sleeping after it sets it after that first one. Oh, that's the issue. Yeah, so here's the 146 solution that you guys are talking about. AK Sister Self says it's not 25 in most tests. Yeah, that is true. So you can't do that. It is a cool solution though, because it's yeah. I really like this trick. That's cute. Also totally didn't need the larger one for this. But a lot of the times you find certain rules too, like when you look at the data set, like whenever this is 50, it always seems to be 0 for a cycle after. No, never mind. That breaks down here. Yes, you can't rely on those tricks in this case. A lot of the time in this game you can, though. But it doesn't look like it's feasible here. Okay, so it just says that's, yeah, basically need to run 2 commands, and that's sleep and test at 60 ticks, around 60 ticks. And some other command, 1 every 5 ticks or 2 every 10 ticks. It sounds impossible, yeah. I like that way of thinking about it, though. In theory, 25 should appear about 33% of the time. And the bad part is we're checking for it all the time. But we really only need to check. Sometimes you can get really cheeky with this stuff. And do stuff like sleep 3 here. Or sleep 2. Because it's like, oh no, that doesn't cover these cases, does it? Yeah, also wouldn't have covered a couple cases in there. Okay, so it just says, yeah, you can add a RAM and store the amount of appearances of values, then can at least get statistics. That's a good idea. I'm starting to get tired and lazy though, so I might shut her down for now. Okay, so it just says that's useless, I think. It might be, but still might be useful. Anyway, I think I'm going to head to bed, actually. But this was pretty fun, guys. So I'll probably have to do this a little more later as well. So I'm going to do that. Anyway, thanks for watching, guys. Thanks for helping out. This is really fun. I'll see you guys later. Okay, Citrus, if you follow me on Twitter, I'll at least announce when I'm streaming Whatev, and I'll probably stream more of this game because this is pretty cool. Anyway, see you later.